Let's look at problem 5 here from the review sheet. Jennifer Roberts started her retirement account with $723,200. She has been withdrawing $5,000 per month from her account. Part A says, write the linear function f of x. Okay? Well, if it's a linear function, f of x, we know it has this form, where m would be the slope. That's how the function value is changing for every value of x, plus b. b is the value when x is 0. b is the function's value when x is 0. Because b, remember, is the y-intercept, and that's what the function is. The function is just a replacement for y. So it says, write the linear function that expresses the amount remaining in her account. Okay? So the function represents the amount left in her account. That's what the function, that's what this value is, the amount left. Based on the number of months x. So x is the months since she started withdrawing funds. So we need to try to create that linear function. So x is months, and f of x, the function, is the amount she has left. Well, do we know anything about how this amount left is changing based upon the months? Well, yes, we do. The amount she has left is changing by $5,000 every month, isn't it? Because she's been taking out $5,000 per month. So she's withdrawing $5,000. So that's our slope. That's our m value. And in this case, it's a negative value. She's taking out $5,000. So the amount left is decreasing by $5,000 for every month since she started taking the money out. Well, do we know what the b value is? Yes, we do, because the b value would be the amount she has left when she hasn't started taking anything out. Remember, when x is 0. X being 0 means she hasn't started taking any money out. Well, that's how much she started with. She started with $723,200. So this is what she started with. At month 0, she had that much money, and now every month from then on, she's been withdrawing $5,000. So this linear function tells us how much she would have left. So there's our linear function. Now it says, how much is in her retirement account after 18 months? So we're wanting to evaluate this function when x is 18. So we would simply put in 18 for x, do the arithmetic. So 18 times negative 5,000, that's 90,000, negative 90,000. After 18 months, she would have withdrawn $90,000. And if she'd started with $723,200, then she would have $633,200 left. So $633,200 left after 18 months. Now, the last part says, how long will it take to deplete her retirement account? Ignore any interest she might earn in her account in all your calculations, because she would be earning some interest, but this will just give us kind of a rough idea. So how long would it take for her to deplete her retirement account? Well, depleting her retirement account means she has how much left? She has nothing left, right? So we would want to see, given this function, how many months will it take for the function value to reach 0. So the amount she has left is 0. So we could actually solve this equation to determine that. So 5,000x equals 723,200. Oops, too many zeros there. So dividing 723,200 by 5,000 gives us an answer of 144.64. Well, this is months, right? X is months, so 144 months, that's roughly 12 years, isn't it? So she can withdraw that kind of money for about, what, 12 and a half years, approximately 12 years? So her retirement account would be depleted. She could withdraw it for all 12 years. Actually, probably we could say that in the 13th year she would finally run out of money, wouldn't she? So here's another example of a linear function, only in this case in a slightly different environment, where we were withdrawing money from an amount of money that we started with, and so our slope ended up being negative. And from that function we were able to answer those questions.